Good afternoon. Up till now, we have seen artificial neural network. We have seen yesterday feed-forward neural networks also. Again, today I will revise for 1 or 2 minutes. Then we will see supervised learning, unsupervised learning, and other types of learning. We will see comparison also. We will see videos also. Therefore, feed-forward neural network, feed-forward. Name itself indicates that direction of input is in the forward direction. Feed means input. The simplest form of neural networks where input data travels in one direction only, passing through artificial neural nodes and exiting through output nodes. Therefore, these are the input nodes. They are passing through these artificial neural nodes, and this is nothing but output nodes. Where hidden layers may or may not be present, input and output layers are present there. Sometimes now in between input layer and output layer, some layers are there. That layers are known as hidden layers. Based on this, they can be further classified as a single layered or multi-layered feed forward neural network. Number of layers depends on the complexity of the function. It has unidirectional forward propagation but no backward propagation. Weights are static here. An activation function is fed by inputs which are multiplied by weights. To do so, classifying activation function or step activation function is used. For example, the neuron is activated if it is above threshold, usually 0, and the neuron produces 1 as an output. The neuron is not activated if it is below threshold, usually 0, which is considered as -1. They are fairly simple to maintain and are equipped with to deal with data which contains a lot of noise. Now, what are the advantages of feed-forward neural network? Less complex, easy to design and maintain, fast and speedy, that is one-way propagation, highly responsive to noisy data. Then disadvantage of feed-forward neural networks. Cannot be used for deep learning due to absence of dense layers and back propagation. Now, there are different learning techniques in neural networks. Supervised learning. Supervised learning means what? It is under the guidance of supervisor. Just now I am taking lecture and all of you are attending. Therefore, that is known as supervised learning. Unsupervised learning means what? It is nothing but self-study. If you are going to do the self-study, then it is known as unsupervised learning. And next is reinforcement learning. Reinforcement learning means what? Reinforce means already I have taught you something and again I am giving some additional data for learning to all the students. That is known as reinforcement learning. Now these are the videos, these links we will see afterwards. First of all, we will see the theory of supervised learning, unsupervised learning and reinforcement learning. The amount of data generated in the world today is very huge. This data is generated not only by humans but also by smartphones, computers, and other devices. Based on the kind of data available and a motive present, certainly a programmer will choose how to train an algorithm using a specific learning model. Machine learning is a part of computer science where the efficiency of a system improves itself by repeatedly performing the tasks by using data instead of explicitly programmed by programmers. Further, let us understand the difference between three techniques of machine learning, that is supervised, unsupervised, and reinforcement learning. Now, first is supervised learning. Consider yourself as a student sitting in a classroom wherein your teacher is supervising you, how you can solve the problem or whether you are doing correctly or not. Likewise, in supervised learning, input is provided as a labeled data set A model can learn from it to provide the result of the problem easily. Now, there are different types of problems in supervised learning. Supervised learning deals with two types of problems: classification problems and regression problems. Now, classification problems. This algorithm helps to predict a discrete value. It can be thought the input data as a member of a particular class or group. For instance, taking of the photos of the fruit data set. Each photo has been labeled as a mango, an apple, etc. Here, the algorithm has to classify the new images into any of these categories. Examples: naive Bayes classifier, support vector machines, logistic regression. Next is regression problems. These problems are used for continuous data. For example, predicting the price of a piece of land in a city given the area, location, number of rooms, etc. And then the input is sent to the machine for calculating the price of the land according to previous examples. Examples are linear regression, non-linear regression, and Bayesian linear regression. Now next is unsupervised learning. This learning algorithm is completely opposite to supervised learning. In short, there is no complete and clean label dataset in unsupervised learning. Unsupervised learning is self-organized learning. Its main aim is to explore the underlying patterns and predicts the output. Here we basically provide the machine with data and ask to look for hidden features and cluster the data in a way that makes sense. Example: K-means clustering, neural networks, principal component analysis. Now next is reinforcement learning. It is neither based on supervised learning nor unsupervised learning. Moreover, here the algorithms learn to react to an environment on their own. It is rapidly growing and moreover producing a variety of learning algorithms. These algorithms are useful in the field of robotics, gaming, etc. For a learning agent, there is always a start state and an end state. However, to reach the end state, there might be a different path. In reinforcement learning, an agent tries to manipulate the environment. The agent travels from one state to another. The agent gets the reward, that is appreciation, on success, but will not receive any reward or appreciation on failure. In this way, the agent learns from the environment. Now, what are the key differences between supervised, unsupervised learning and reinforcement learning? First, supervised learning deals with two main tasks: regression and classification. Unsupervised learning deals with clustering and associative rule mining problems, whereas reinforcement learning deals with exploitation or exploration, Markov's decision processes, policy learning, deep learning, and value learning. Next, supervised learning works with the label data, and here the output data patterns are known to the system. But the unsupervised learning deals with unlabeled data, where the output is based on the collection of perceptions. Whereas in reinforcement learning, Markov's decision process, the agent interacts with the environment in discrete steps. The name itself says supervised learning is highly supervised and unsupervised learning is not supervised. As against reinforcement learning is less supervised, which depends on the agent in determining the output. The input data in supervised learning is in label data, whereas In unsupervised learning, the data is unlabeled. The data is not predefined in reinforcement learning. Fifth, supervised learning predicts based on a class type. Unsupervised learning discovers underlying patterns, and in reinforcement learning, the learning agent works as a reward and action system. Supervised learning maps label data to known output, whereas unsupervised learning explore patterns and predict the output. Reinforcement learning follows a trial and error method. To sum up, in supervised learning, the goal is to generate formula based on input and output values. In unsupervised learning, we find an association between input values and group them. In reinforcement learning, an agent learns through delayed feedback by interacting with the environment. Now, this is the comparison table. Criteria, supervised learning or supervised machine learning, unsupervised machine learning, and reinforcement machine learning. First criteria is definition. In supervised learning, learns by using labeled data. Then unsupervised, trained using unlabeled data without any guidance. Reinforcement machine learning works on interacting with the environment. Then type of data, labeled data, unlabeled data, no predefined data. Type of problems, regression and classification, association and clustering, exploitation or exploration. Supervision, extra supervision, no supervision, no supervision. Algorithms, linear regression, logistic regression, SVM, KNN, etc. K means, C means a priori. Q learning, then SARSA. Aim, calculate outcomes, discover underlying patterns, learn a series of action. Application, risk evaluation, forecast sales, recommendation system, anomaly detection, self-driving cars, gaming, healthcare. Therefore, this is the comparison. Now we will see the videos, then you will understand what is meant by again supervised learning and unsupervised learning. First of all, we will see this video.
Helps you work more efficiently, which makes accomplishing your work goals easier than ever before. Get full.
Do you want to learn a cutting-edge technology such as AI and dominate the market? Do you want to stand out from the millions of others but don't know where to begin? Do you want to receive inbound opportunities? हेलो दोस्तों, गेट्स मैशेस में आपका स्वागत है। आज की इस वीडियो में हम डिस्कस करने जा रहे हैं वेरियस टाइप्स ऑफ लर्निंग्स इन एआई, या बोल सकते हो वेरियस टाइप्स ऑफ मशीन लर्निंग्स। तो यहाँ पे अगर हम बात करें मशीन लर्निंग के अंदर हमारे पास डिफरेंट टाइप ऑफ लर्निंग जो आती है वो है सुपरवाइज्ड, अनसुपरवाइज्ड और रीइंफोर्समेंट। और बहुत जगह पे इन तीनों के बीच में डिफरेंस के बारे में पूछा जाता है। और यहाँ पे इस वीडियो में मैं आपको बहुत ही सिंपल लेवल से और रियल लाइफ एग्जांपल, जैसे कि पीके मूवी की अगर हम बात करें या इलेक्शंस का जो एग्जिट पोल की बात करें, तो उसी के एग्जांपल्स के बेसिस पे इन तीनों के बीच में डिफरेंस बताने जा रहा हूं और इनका जो बेसिक इंट्रोडक्शन है वो मैं यहाँ पे देने जा रहा हूं। तो यहाँ पे अगर हम स्टार्ट करते हैं सुपरवाइज्ड लर्निंग से, तो जैसा कि मशीन लर्निंग की अगर हम बात करें या आर्टिफिशियल इंटेलिजेंस की बात करें, तो हमारा मेन एम क्या है कि कैसे मशीन्स को इंटेलिजेंट बनाया जाए। और किसी भी मशीन को इंटेलिजेंट बनाने का सबसे मेन फैक्टर क्या है कि वो खुद से लर्न करे। तो यहाँ पे हमारे पास तीन टाइप के जो लर्निंग है, सुपरवाइज्ड, अनसुपरवाइज्ड रीइंफोर्समेंट। ये मेन 3 लर्निंग है। वैसे तो डिफरेंट टाइप ऑफ लर्निंग्स और भी है हमारे पास। तो सुपरवाइज लर्निंग से हम स्टार्ट कर रहे हैं। पहले मैं आपको एक बेसिक टेक्निकल इंट्रोडक्शन दे रहा हूं। तो यहाँ पे सुपरवाइज लर्निंग में हमारे पास क्या होता है, ट्रेनिंग डेटा। मतलब कहने का क्या है, नाम से ही पता लग रहा है सुपरवाइज, मतलब यहाँ पे हमारे पास एक सुपरवाइजर है। सुपरवाइजर का मतलब एक टीचर है जो हमें कुछ इंस्ट्रक्शन दे रहा है। वो यहाँ पे कौन है, ट्रेनिंग डेटा। ट्रेनिंग डेटा का मतलब है हमारे पास ऑलरेडी इनपुट भी है, हमारे पास आउटपुट भी अवेलेबल है, और उसी इनपुट आउटपुट के बेसिस पे उस ट्रेनिंग डेटा को या उस लेबल्ड डेटा के बेसिस पे हम एक मॉडल तैयार करते हैं, और उस मॉडल में हम न्यू इनपुट डाल के देखते हैं और चेक करते हैं कि क्या वैलिड आउटपुट आ रहा है या नहीं आ रहा। कहने का मतलब क्या है, अगर एक सिंपल से एग्जांपल से मैं आपको समझाऊं, तो एग्जिट पोल, जैसे कि अभी आपने देखा होगा कि बहुत सारे चैनल्स ने एग्जिट पोल दिया था इस लोकसभा इलेक्शन का। तो लोकसभा इलेक्शन के जो एग्जिट पोल है वो क्या है, एक ट्रेनिंग डेटा है। ट्रेनिंग डेटा का मतलब है हजारों लोगों से, लाखों लोगों से उन्होंने फीडबैक लिया, और उसमें अलग अलग कैटेगरी के लोगों से, ऐसा नहीं कि सिर्फ यंगस्टर से लिया, यंगस्टर से भी लिया, बच्चों से भी लिया, बड़े बुजुर्गों सबसे लिया उन्होंने फीडबैक। और उस फीडबैक में है क्या, उनका इनपुट, और उस इनपुट के बेसिस पे एक आउटपुट की बीजेपी को इतनी सीटें आएंगी, कांग्रेस को इतनी आएंगी या इसको इतनी आएंगी, ये विनिंग कैंडिडेट है, ये लॉसिंग कैंडिडेट है। तो ये जो सारे पॉइंट्स हैं उन्होंने ऑलरेडी ट्रेनिंग डेटा में डाल दिया, और ये हमारा ट्रेनिंग डेटा के बेसिस पे हम इसके ऊपर काम कर रहे हैं। मतलब हमने मशीन को ये डेटा जो है वो दे दिया। अब लर्निंग एल्गोरिदम्स यहाँ पे काम करेंगे। कौन कौन से लर्निंग एल्गोरिदम का यहाँ पे हम यूज करते हैं, जैसे ने बेस एल्गोरिदम। जो ने बेस है वो क्या करता है, सुपरवाइज लर्निंग पे काम कर रहा है, जिसमें आपने इनपुट और आउटपुट जो है वो पहले ही डाल दिया। अब होगा क्या, अब आपने न्यू इनपुट दी। न्यू इनपुट यहाँ पे क्या है, एक्चुअल में जब काउंटिंग स्टार्ट हुई, जो ओरिजिनल डेटा था, जो ओरिजिनल लोगों ने वोट किया, उसका जो डेटा जब आया, और उस डेटा को हमने क्या किया, मॉडल के ऊपर। मॉडल जो है किसके ऊपर बेस्ड था, जो एग्जिट पोल का डेटा था, जो एक डमी डेटा बना के एक फीडबैक के बेसिस पे जो आउटपुट आई थी, उसके बेसिस पे हमने मशीन को मॉडल तैयार किया। मॉडल मतलब एक प्रोटोटाइप किया कि ये जीतेगा, ये हारेगा, ये विनिंग प्रोबेबिलिटी इसकी ज्यादा है, इसकी कम है। अब होगा क्या, जैसे ही हमने न्यू डेटा उसमें डाला या एक्चुअल डेटा डाला, उस मॉडल के बेसिस पे उसने कुछ आउटपुट दिया। अब हमारा जो आउटपुट है वो क्या है, अगर आपका आउटपुट वहां पे करेक्ट आ रहा है, मतलब जो आपने एग्जिट पोल में बोला था वही आपका एग्जैक्ट रिजल्ट आ रहा है, तो ऑब्वियसली आपने जो ट्रेनिंग डेटा दिया वो डेटा जो है बहुत ही अच्छे लेवल का डेटा दिया, बहुत ही रिफाइंड डेटा दिया, और आपका एल्गोरिदम जो है वो प्रॉपरली लर्न करके क्लासिफाई कर रहा है। क्लासिफिकेशन का मतलब है कि डेटा को क्लासिफाई करना कि ये जीतेगा, ये हारेगा, इसकी जीतने की प्रोबेबिलिटी ज्यादा है। तो इस तरीके से हम क्या करते हैं, ऑलरेडी मशीन को हम इनपुट और आउटपुट प्रोवाइड कर देते हैं। तो इसको बोलते हैं हम सुपरवाइज्ड लर्निंग। अनसुपरवाइज्ड लर्निंग की अगर हम बात करें तो इसका सिंपल सा एग्जांपल है पीके मूवी की। अगर हम बात करें तो जैसे ही आमिर खान अपने दूसरे ग्रह से पृथ्वी पे आता है, तो उसको कुछ नहीं पता, मतलब न्यू बॉर्न बेबी की तरह है, उसको कुछ नहीं आइडिया कि क्या सही है क्या गलत है, कौन आदमी कौन औरत, कौन बच्चे कौन बुजुर्ग, कुछ नहीं पता। तो वही सबसे पहला, अगर आपने डेफिनेटली वो सीन देखे होंगे तो आपको पता होगा कि उसको यहाँ पे ये नहीं पता कि लोगों की चमड़ी कैसी है। तो वो कहता है कि किसी की चमड़ी जो है वो ढीली ढाली, किसी की चिपकी हुई, किसी की चमड़ी रंग रंगीली सी है। तो ये एक्चुअल में क्या है, उसको कोई भी नॉलेज नहीं है, सिर्फ उसके पास इनपुट है। इनपुट कहाँ से आ रही है, सेंसर से, मतलब आंखों से वो देख रहा है, कुछ जज कर रहा है, और उसके बेसिस पे वो क्या कर रहा है, उनके फिजिकल स्ट्रक्चर के बेसिस पे, उनकी जो दिखने के चलने के अंदाज के बेसिस पे वो क्या कर रहा है, ग्रुप कर रहा है, क्लस्टर बना रहा है। वहां पे क्लस्टर का मतलब क्या है कि उसने देख लिया कि अगर किसी की मूछें हैं, किसी की हाइट अच्छी है, या किसी ने कुर्ता पजामा टाइप ढीले ढीले कपड़े पहने हैं, तो वो मतलब उसने एक पुरुषों वाली कैटेगरी में रख दिया, मतलब जेंट्स वाली कैटेगरी में रख दिया। ऐसी उसने लेडीज की कैटेगरी बनाई, खेलने वालों की अलग बनाई, बच्चों की अलग कैटेगरी आई। ऐसा नहीं कि वो कैटेगरी बिल्कुल सही है, एक 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 फर्स्ट लेवल पे उसने क्या किया, ग्रुप बना दिए, क्लस्टर बना दिए। तो ये क्या है, हमारे पास सिर्फ और सिर्फ इनपुट है, आउटपुट नहीं है। उसको नहीं पता कि ये चीज क्या है, और धीरे धीरे वो लर्न कर रहा है, अपने आप से लर्न करते करते वो क्या कर रहा है, एक्चुअल जो आउटपुट की तरफ जा रहा है। यहाँ पे हमारे पास क्या है, के मीन जैसे कि एल्गोरिदम को हम यूज करते हैं, तो के मीन क्लस्टरिंग के अंदर हम क्या करते हैं, हम ग्रुप बनाते हैं, और जो सेम टाइप के बंदे हैं उनको एक ग्रुप में रखने की कोशिश करते हैं। तो ये अनसुपरवाइज लर्निंग जो है ज्यादातर मशीन्स आपकी अनसुपरवाइज्ड लर्निंग में ही आती है, क्योंकि मशीन्स के पास अपना तो ब्रेन है नहीं, तो ऑब्वियसली वो क्या करती है, उनको हमने सुपरवाइज्ड देना पड़ता है, मतलब उनको पहले डेटा देना पड़ता है, उसके बेस पे वो कुछ कुछ आउटपुट जनरेट करते हैं या कुछ डिसीजन जो है वो मेक करते हैं। तो यहाँ पे थर्ड की अगर हम बात करें, रीइंफोर्समेंट लर्निंग। रीइंफोर्समेंट लर्निंग में क्या होता है, हमारे पास रिवॉर्ड एंड पॉलिसी के ऊपर बेस्ड है। रिवॉर्ड एंड पॉलिसी मतलब कहने का कि हमारे पास एक एजेंट है, एजेंट मतलब कोई भी ले लो, जैसे पीके में आमिर खान जो है वो एक एजेंट है, उस एजेंट ने कुछ एक्शन परफॉर्म किया, कहाँ, इन्वायरमेंट, जो पूरा का पूरा इन्वायरमेंट है उसके अंदर कुछ एक्शन परफॉर्म किया, और उस एक्शन के बेस पे उसको या तो कुछ रिवॉर्ड मिला, मतलब कुछ प्लस में मिला, या कुछ नेगेटिव मिला जिसको हम पेनल्टी बोल सकते हैं, और स्टेट जो है वो कुछ चेंज हुई। स्टेट चेंज होगी क्या, मतलब इन्वायरमेंट में कुछ चेंज किया, फिर उसने उसके बेसिस पे कुछ पॉलिसी बनाई, और नेक्स्ट टाइम उस पॉलिसी के बेसिस पे वो उसको अलग तरीके से परफॉर्म करेगा। मतलब आपने वो सीन देखा होगा जिसमें वो 50 रुपीज का नोट जो है, 50 रुपए का नोट देता है और उसको उसके बदले में गाजर मिलती है, तो उसको क्या लगता है यहाँ पे कि जैसे उसने एक्शन परफॉर्म किया, 50 रुपए का नोट दिया, वहां पे स्टेट चेंज हो गई और रिवॉर्ड क्या मिला, गाजरों का एक पूरा बंडल दे दिया। अब होगा क्या, उसने सोचा कि उसने एक पॉलिसी बनाई कि इस बंदे की जो तस्वीर है जहां जहां पे लगी है उसको उठा लो, तो वो सारी जगह से महात्मा गांधी की तस्वीर उठा के लाता है और उस बंदे को दोबारा देता है। जैसे ही वो दोबारा देता है वो उसको रिकॉग्नाइज नहीं करता, तो वो बाद में यही सबसे बड़ा मैसेज भी वो देता है कि इस फोटो की जो कीमत है सिर्फ एक ही कागज पे, बाकियों पे नहीं है। तो ये एक्चुअल में एग्जांपल क्या है, रीइंफोर्समेंट का, जहां पे वो पेनल्टी और रिवॉर्ड के बेसिस पे एक पॉलिसी बना रहा है और उस पॉलिसी में चेंज करते करते वो क्या कर रहा है, लर्न करता है। जनरली ये होता है गेम्स के अंदर, गेम्स में आपने एक स्टेप लिया और आपको पॉइंट मिला, पॉजिटिव में पॉइंट मिला या नेगेटिव में पॉइंट मिला, उसके बेसिस पे आप एक पॉलिसी डिजाइन करोगे कि नेक्स्ट टाइम आपको ऐसा स्टेप या इससे सिमिलर स्टेप चलना चाहिए या नहीं। तो ये बेसिकली एग्जांपल है। आप सबसे पहले जो है अनसुपरवाइज लर्निंग से स्टार्ट करते हैं हम हमेशा, कि जहां पे कोई नॉलेज नहीं है, सिर्फ हमारे पास इनपुट ही इनपुट है, हमें कुछ नहीं पता, तो यहाँ पे वो अपने बेसिस पे कुछ क्लस्टर बनाता है। क्लस्टर कुछ भी हो सकते हैं, बेस्ड ऑन देयर फिजिकल स्ट्रक्चर, बेस्ड ऑन देयर कलर, बेस्ड ऑन देयर कि वो कैसे दिखते हैं, उसके बेसिस पे स्ट्रक्चर, उसके बेसिस पे क्लस्टर बनाएगा, फिर धीरे धीरे उन क्लस्टर्स को रिफाइन करेगा। कल को हो सकता है और लोगों से उसको फीडबैक मिली, धीरे धीरे करते करते वो जो है क्लस्टर्स को रिफाइन करता जाएगा। जब एक बार क्लस्टर बन गए, अब उसने जैसे ही देखा एक ड्रेस पहनी हुई लड़की को, तो साथ के साथ उसको पता लग जाएगा कि ये क्या है, लड़की है, तो ऑब्वियसली वो किस तरफ डालेगा, वो क्लासिफाई करके उसको लड़कियों वाले ग्रुप में ही डालेगा। मतलब पहले अनसुपरवाइज्ड करते करते वो सुपरवाइज्ड लर्निंग में पहुंच जाएगा। तो ये मेन डिफरेंस है सुपरवाइज्ड, अनसुपरवाइज्ड एंड रीइंफोर्समेंट। रीइंफोर्समेंट में हम जनरली यूज करते हैं क्यू लर्निंग मेथड। बहुत सारे एल्गोरिथम्स हैं, लेकिन अगर इतने एल्गोरिथम्स को भी आप कर लेते हो, इनको आप इंप्लीमेंट कर सकते हो बाय यूजिंग पाइथन, आप मैटलैब पे भी इंप्लीमेंट कर सकते हो, आर प्रोग्रामिंग के थ्रू भी इनको आप इंप्लीमेंट कर सकते हो। थैंक यू।
Okay, we'll see now next video.
Hi guys, this is Zulekha from EduReka. The evolution of AI has changed the entire 21st century. In terms of technology, AI has stolen the spotlight and its advancements are quicker than we predicted. With such an exponential growth in AI, machine learning is becoming the most trending field of the 21st century. It is starting to redefine the way we live, and it's time we understood what it is and why it matters. In this session, we'll be discussing the different types of machine learning and we'll compare them to each other. So let me run you through today's agenda. We're going to begin this session with an introduction to machine learning. Next, we'll discuss the types of machine learning. After that, we'll compare supervised, unsupervised, and reinforcement learning based on a few key parameters. We'll finally end the session by discussing a few example problems that can be solved using supervised, unsupervised, and reinforcement learning algorithms. So without any further delay, let's get started. So guys, machine learning is the science of getting computers to act by feeding them data and letting them learn a few tricks on their own without being explicitly programmed. Now, this sounds awfully a lot like a human child. So let's consider a small scenario to understand machine learning. Now, as a child, if you had to distinguish between fruits such as cherries, apples, and oranges, you wouldn't even know where to start because you're not familiar with how the fruits look. Now, as we grow up, we collect more information and start developing the capability to distinguish between various fruits. The only reason why we are able to make this distinction is because we observed our surroundings, we gathered more data, and we learned from our past experiences. It's because our brain is capable enough to think and make decisions since we have been feeding it a lot of data. And this is exactly how machine learning works. It involves continuously feeding data to a machine so that it can interpret this data, understand the useful insights, detect patterns, and identify key features to solve problems. This is very similar to how our brain works. Now let's move ahead and take a look at the different types of machine learning. So first of all, we have supervised learning. Now guys, supervised means to oversee or direct a certain activity and make sure it's done correctly. In this type of learning, the machine learns under guidance. So at school, our teachers guided us and taught us. Similarly, in supervised learning, machines learn by feeding them labeled data and explicitly telling them, hey, this is the input and this is exactly how the output must look. Okay, so the teacher in this case is a training data. Next, we have unsupervised learning. Unsupervised means to act without anyone's supervision or without anybody's direction. Now here the data is not labeled, there is no guide, and the machine has to figure out the data set given and it has to find hidden patterns in order to make predictions about the output. An example of unsupervised learning is an adult like you and me. We don't need a guide to help us with our daily activities. We can figure things out on our own without any supervision. Finally, we have reinforcement learning. Now, guys, reinforcement means to establish or encourage a pattern of behavior. Let's say that you were dropped off at an isolated island. What would you do? Now, initially, you'd panic and you'd be unsure of what to do, where to get food from, how to live, and so on. But after a while, you will have to adapt. You must learn how to live in the island, adapt to the changing climates, learn what to eat and what not to eat. So here you're basically following the hit and trial concept because you're new to the surrounding and the only way to learn is experience and then learn from your experience. This is what reinforcement learning is. It is a learning method wherein an agent, which is basically you stuck on the island, interacts with its environment, which is the island, by producing actions and discovers errors or rewards. And once the agent gets trained, it gets ready to predict the new data presented to it. Now let's move ahead and look at the differences between supervised, unsupervised, and reinforcement learning. So let's begin by looking at their definitions. Now, like I mentioned earlier, supervised learning is a type of machine learning wherein we teach the machine using labeled data. So your input and your output is labeled. Next, we have unsupervised learning. Over here, the data provided to the machine is not labeled, and the machine has to learn without any supervision. So that's why it should discover hidden patterns and trends in the data. Finally, we have reinforcement learning. Now, the basic concept behind reinforcement learning is that there is an agent. Now, this agent is put in an unknown environment. So the agent has to explore the environment by taking actions and transitioning from one state to the other so that he can get maximum rewards. Now, the next parameter to consider is the type of problems that are solved with supervised, unsupervised, and reinforcement learning. So under supervised learning, we have two main categories of problems. We have regression problems and we have classification problems. Now guys, there's an important difference between classification and regression. Basically, classification is about predicting a label or a class, whereas regression is about predicting a continuous quantity. Now let's say that you have to classify your email into two different groups. So here basically we'll be labeling our emails as spam and non-spam mails. For this kind of problem where we have to assign our input data into different classes, we make use of classification algorithms. On the other hand, regression is used to predict a continuous quantity. Now, a continuous variable is a variable that has infinite number of possibilities. For example, a person's weight. So someone could weigh 180 pounds, or they could weigh 180.10 pounds or 180.110 pounds. Now, the number of possibilities for weight are limitless, and this is exactly what a continuous variable is. So regression is a predictive analysis used to predict continuous variables. Here, you don't have to label data into different classes. Instead, you have to predict a final outcome, like let's say that you want to predict the price of a stock over a period of time. For such problems, you can make use of regression algorithms. Coming to unsupervised learning, this type of learning can be used to solve association problems and clustering problems. Association problems basically involve discovering patterns in data, finding co-occurrences, and so on. A classic example of association rule mining is a relationship between bread and jam. So people who tend to buy bread also tend to buy jam. Over here, it's all about finding associations between items that frequently co-occur or items that are similar to each other. Apart from association problems, unsupervised learning also deals with clustering and anomaly detection problems. Clustering is used for cases that involve targeted marketing, wherein you are given a list of customers and some information about them. And what you have to do is you have to cluster these customers based on their similarity. Now, guys, digital AdWords use a clustering technique to cluster potential buyers into different categories based on their interests and their intent. Anomaly detection, on the other hand, is used for tracking unusual activities. An example of this is credit card fraud, wherein various unsupervised algorithms are used to detect suspicious activities. Then there is reinforcement learning. Now, this type of learning is comparatively different. In reinforcement learning, the key difference is that the input itself depends on the actions we take. For example, in robotics, we might start in a situation where the robot does not know anything about the surrounding it is in. So after it performs certain actions, it finds out more about the world. But the world it sees depends on whether it chooses to move right or whether it chooses to move forward or backward. In this case, the robot is known as the agent and its surrounding is the environment. So for each action it takes, it can receive a reward or it might receive a punishment. Now, the next parameter is the type of data used to train a machine. When it comes to supervised learning, it's quite pure and simple. The machine will be provided with a labeled set of input and output data in the training phase itself. So basically, you feed the output of your algorithm into the system. This means that in supervised learning, the machine already knows the output of the algorithm before it starts working on it. Now, an example is classifying a data set into either cats or dogs, right? So if the algorithm is fed an image of a cat, the image is labeled as a cat. Similarly for a dog. So guys, this is how the model is taught. It's told that this is a cat by labeling it. After the algorithm is taught, it is then tested using a new data set. But a point to remember here is that in the training phase, for a supervised learning algorithm, the data is labeled. All right, the input is also labeled and the output is also labeled. In unsupervised learning, the machine is only given the input data. So here we don't tell the system where to go. The system has to understand itself from the input data that we give to it. So it does this by finding patterns in the data. So if we try to classify images into cats and dogs, in unsupervised learning, the machine will be fed images of cats and dogs, and at the end, it will form two groups, one containing cats and the other containing dogs. Now, the only difference here is that it won't add labels to the output. Okay, it will just understand how cats look and cluster them into one group, and similarly for dogs. Coming to reinforcement learning, there is no predefined data. The input depends on the actions taken by the agent. Now, these actions are then recorded in the form of matrices so that it can serve as a memory to the agent. So basically, as the agent explores the environment, it will collect data, which will then be used to get the output. So guys, in reinforcement learning, there is no predefined data set given to the machine. The agent does all the work from scratch. The next parameter to consider is training. In Supervised learning, the training phase is well defined and very explicit. The machine is fed training data where both the input and output is labeled, and the only thing the algorithm has to do is map the input to the output. So the training data acts like a teacher or a guide over here. Now, once the algorithm is well trained, it's tested using the new data. When it comes to unsupervised learning, the training phase is big because the machine is only given the input and it has to figure out the output on its own. So there's no supervisor here or there's no mentor over here. In reinforcement learning, there is no predefined data, and the whole reinforcement learning process itself is a training and testing phase. Since there is no predefined data given to the machine, it has to learn everything on its own, and it starts by exploring and collecting data. The next parameter we're going to discuss is the aim of each of these machine learning types. The main aim or the end goal of a supervised learning algorithm is to forecast an outcome. Now, obviously, that is the basic aim of all these machine learning types, but the whole supervised learning process is built in such a way that it can directly give you a predicted outcome because supervised learning algorithms have a very well-defined training phase. Unsupervised learning is all about discovering patterns and extracting useful insights. Now, since the algorithm is only fed the input, it has to find a way to get to the output by finding trends and associations in the data. Coming to reinforcement learning, the agent here is a lot like a human child. Just like how a baby is clueless about the world, initially the agent also has no idea about its environment. But as it explores the environment, it starts learning. It learns from the mistakes it makes and it basically learns from its experience. Now let's look at the approach followed. When it comes to supervised learning, it's quite simple. Like I mentioned earlier, all that the algorithm has to do is map the known input to the known output. In unsupervised learning, the algorithm has to find patterns in data, trends in data, and keep exploring the data until it reaches the output. The approach followed by reinforcement learning is a trial and error method. The trial and error method best explains reinforcement learning because the agent has to try out all possible actions to learn about its environment and get maximum rewards. The next parameter is feedback. Now, in supervised learning, there is a direct feedback mechanism since the machine is trained with labeled input and output. For unsupervised learning, there is no feedback mechanism because the machine is unaware of the output during the training phase. Now, in reinforcement learning, the feedback is in the form of rewards or punishments from the environment. So, when an agent takes a suitable action, it will get a corresponding reward for that action. But if the action is wrong, then it gets a punishment. So rewards and punishments can be thought with respect to a game. Now, in a game, when you win a state, you get extra coins. But when you fail, you have to go back to the same state and try again. Now, let's look at some of the popular algorithms. Supervised learning has algorithms like linear regression, which is mainly used for regression problems. It also has algorithms like support vector machines, decision trees, and so on. And these can also be used for classification problems. Coming to unsupervised learning, we have algorithms like k-means, c-means for clustering analysis, and algorithms like a priori and association rule mining to deal with association problems. Now, reinforcement learning is just being explored recently. A few algorithms include Q-learning and the state action reward state action algorithm. Next up, we have applications. So guys, supervised learning is widely used in the business sector for forecasting risk, risk analysis, predicting sales, profit, and so on. Coming to unsupervised learning. So guys, the recommendations you see when you shop online, like for example, if you buy a book on Amazon, right, you get a list of recommendations. Now, these are all done by unsupervised learning algorithms. Other applications include anomaly detection, credit card fraud detection, and so on. Now, reinforcement learning is used in self-driving cars, in building games, and all of that. One famous example is the AlphaGo game. I'm sure all of you have heard of that. So guys, those were the major differences between supervised, unsupervised, and reinforcement learning. So now let me give you a few examples of problems that can be solved using supervised, unsupervised, and reinforcement learning algorithms. All right, so our first use case is to study a bank credit data set and make a decision about whether to approve the loan of an applicant based on his profile. So here we're going to be given a bank credit data set. Now the information that you see over here is for each of the customers. So every customer's account balance, purpose, credit amount, value, savings, everything is given in the data set, and you have to predict whether you can approve the loan of an applicant based on his bank account balance, based on his purpose, his credit amount, and his savings. So for this problem, you can make use of the supervised learning algorithm known as KNN algorithm or K-nearest neighbor algorithm. Now let's look at our next use case. Now here we have to establish a mathematical equation for distance as a function of speed. So basically over here, you're going to predict the distance that a car can travel based on its speed. So guys, the best algorithm to use for such a problem is the linear regression algorithm. So the linear regression algorithm is basically used to predict continuous quantities. And in this case, we have to predict the distance, which is a continuous quantity. And like I mentioned earlier, a linear regression is a type of supervised learning algorithm. Okay, moving on to our next use case. Now the problem here is to cluster a set of movies as either good or average based on their social media outreach. All right, now if you read the problem statement properly, you can see the word cluster. All right, this clearly means that this is a clustering problem, and clustering problems fall under unsupervised learning. So here we're going to make use of an algorithm known as K-means algorithm to form two clusters. Okay, one cluster is going to contain popular movies, and the other is going to contain non-popular movies based on their likes on social media. Now, moving ahead, our next problem statement is to perform market basket analysis by finding association between items bought at the grocery store. Again, over here, you can see the keyword association. This means that's an association problem. Now, association problems fall under the unsupervised learning algorithms. And here we can make use of the a priori algorithm to do this. So here what you have to do is basically, you have to try and find association between different items. So if a person bought bread and butter together, it means that there is an association between these two items. So in this problem, you're just going to find the association between different items, and you're going to make use of the unsupervised learning algorithm called the a priori algorithm. So guys, this is the last use case, and over here the problem statement says that you're going to place an agent in any one of the rooms, and basically the rooms are represented as 0, 1, 2, 3, 4, and 5. And the goal here is to reach the outside of the building. Now, this is clearly a reinforcement learning problem. All right. To solve this, you can make use of the Q-learning algorithm, and your end goal is to reach room number 5. So guys, here you can see that there is no data set because the data set is going to be developed by the agent itself. So guys, over here, the agent is responsible for collecting the data. All right, he's going to explore the environment, collect useful information, and then he's going to use this information to get to room number 5. So guys, that was it for our use cases. And with this, we come to the end of today's video. I hope all of you enjoyed it. If you have any doubts or any queries regarding the session, please leave them in the comment section and we'll get back.
Okay, this is nothing but supervised learning, unsupervised learning, and reinforcement learning. Therefore, some initial data of what is supervised, unsupervised, and what is that videos I will post at 3:30. Therefore, I think we will stop here. Let me take your attendance.